Humans have long been fascinated by the underwater world. We watch fish swim effortlessly, breathing underwater as easily as we breathe air. This begs the question, could we ever do the same? Could humans ever breathe underwater like fish? The answer, unfortunately, is not so simple. While the ocean holds a certain allure, our biology is intrinsically tied to the air we breathe. Our lungs, perfectly adapted for extracting oxygen from the atmosphere, are simply not equipped to handle water. So, while the dream of breathing underwater might seem like something out of science fiction, the reality is much more complicated. To understand why, we need to delve into the fundamental differences between our respiratory system and that of aquatic creatures. Let's explore the science behind our limitations and the potential solutions that might one day allow us to experience the underwater world like never before. To understand why humans can't breathe underwater, we need to look at how our respiratory system works. Our lungs are designed to extract oxygen from the air. When we inhale, our lungs fill with air, and oxygen passes into our bloodstream. Carbon dioxide, a waste product, moves from the blood into the lungs and is expelled when we exhale. Water is far denser than air and contains significantly less dissolved oxygen. Our lungs, accustomed to the lightness and oxygen-rich nature of air, are ill-equipped to extract enough oxygen from water to sustain us. Furthermore, attempting to breathe water would be disastrous. Our lungs aren't designed to handle the influx of liquid. Water in the lungs can disrupt the delicate gas exchange process and lead to a life-threatening condition called pulmonary edema. Therefore, our biology presents a significant hurdle to breathing underwater like fish. Our lungs designed for air are simply not compatible with the aquatic environment. But does that mean the dream of breathing underwater is entirely out of reach? Fish navigate the underwater world with effortless grace, thanks to their remarkable respiratory system gills. These specialized organs allow fish to extract dissolved oxygen from water, enabling them to thrive in aquatic environments. Gills are incredibly efficient at extracting oxygen, far more so than our lungs could ever be in water. They work by passing water over a large surface area of thin, highly vascularized tissues. Oxygen diffuses from the water into the bloodstream, while carbon dioxide is released back into the water. This efficient gas exchange process is crucial for fish survival. But could humans ever develop similar adaptations? Could we evolve to possess gills, allowing us to breathe underwater like our aquatic counterparts? The answer, according to evolutionary biologists, is a resounding no. The idea of humans evolving gills might seem intriguing, perhaps even plausible in a science fiction setting. However, the reality of evolution paints a different picture. Evolution is a slow and gradual process driven by natural selection. For humans to evolve gills, several factors would need to align, and even then it's highly improbable. Firstly, there would need to be a significant environmental pressure favoring underwater breathing. While humans have explored the ocean's depths, we have not faced the same evolutionary pressures as aquatic creatures. Our ancestors evolved to thrive in terrestrial environments, and our physiology reflects that. Secondly, even if humans were to face such pressure, the development of gills would require significant genetic mutations over countless generations. The complex structure and function of gills are the result of millions of years of evolution in fish. It's highly unlikely that humans would undergo such drastic evolutionary changes within a time frame relevant to our species. While the idea of humans naturally evolving gills is improbable, could technology offer an alternative pathway to underwater respiration? Section 5. Artificial gills breathing like a fish. The limitations of our biology have spurred scientists and engineers to explore technological solutions for underwater breathing. One such avenue of research is the development of artificial gills, devices that mimic the function of fish gills to extract dissolved oxygen from water. While still in the early stages of development, artificial gills hold promise for extending our underwater excursions. These devices typically involve a semi-permeable membrane that allows oxygen to pass through while blocking water molecules. Some designs utilize specialized liquids that can absorb oxygen from water and then release it to the user. However, significant challenges remain in creating efficient and practical artificial gills. The concentration of dissolved oxygen in water is far lower than in air, requiring artificial gills to be remarkably efficient at extracting oxygen. Additionally, these devices need to be compact, lightweight, and capable of providing a sufficient oxygen supply for extended underwater activities. While artificial gills may not allow us to breathe underwater like fish just yet, they represent a step towards overcoming our physiological limitations. Section 6. Oxygen from water, a breath of fresh air. Beyond artificial gills, other technologies are being explored to extract oxygen from water, potentially offering an alternative to traditional scuba gear. One such technology involves electrolysis, a process that uses electricity to split water molecules into hydrogen and oxygen. Electrolysis has been used for various applications, including generating oxygen for life support systems in spacecraft. In the context of underwater breathing, electrolysis could be used to extract oxygen from seawater, providing a continuous supply for divers. However, electrolysis requires a significant amount of energy to break the strong bonds between hydrogen and oxygen atoms in water. Developing efficient and portable electrolysis systems for underwater use remains a technical challenge. Despite these challenges, the ability to extract oxygen from water holds immense potential for underwater exploration, research, and even potential underwater habitats. Section 7. Underwater habitats living like aquanauts. The allure of living underwater has captivated imaginations for generations. From Jules Verne's 20,000 Leagues Under the Sea to modern-day underwater research stations, the idea of building submerged habitats continues to fascinate. While living underwater presents significant challenges, it also offers unique opportunities for scientific research, resource exploration, and even tourism. Underwater habitats could provide a platform for studying marine ecosystems, testing new underwater technologies, and experiencing the ocean in a way that was previously unimaginable. However, building and maintaining underwater habitats is a complex and costly endeavor. These structures need to withstand immense pressure, provide life support systems, and ensure the safety and well-being of their inhabitants. Despite the challenges, the development of underwater habitats represents a testament to human ingenuity and our desire to explore and understand the ocean depths. Section 8. The future of underwater living. While the idea of humans breathing underwater like fish might remain firmly in the realm of science fiction, the future of underwater exploration and habitation is brimming with possibilities. As technology advances, we can expect to see continued innovation in artificial gills, oxygen extraction methods, and underwater habitat design. Imagine a future where underwater researchers can work for extended periods studying marine life and ecosystems without the limitations of traditional scuba gear. Picture underwater cities powered by renewable energy sources and designed to coexist harmoniously with the marine environment. While these visions may seem like something out of a science fiction novel, they highlight the potential for humans to expand our presence into the ocean depths in a sustainable and responsible manner. The future of underwater living depends on our commitment to innovation, conservation, and a deep respect for the ocean and its inhabitants. Section 9. Conclusion. Our relationship with the ocean. The question of whether humans can breathe underwater like fish goes beyond a simple yes or no answer. It prompts us to reflect on our relationship with the ocean, the limitations of our biology, and the potential of human ingenuity. While we may never sprout gills or morph into aquatic beings, our desire to explore and understand the underwater world continues to drive innovation and discovery. From artificial gills to underwater habitats, we are constantly pushing the boundaries of what's possible, seeking new ways to experience and interact with the ocean depths. As we venture further into the underwater realm, it's crucial to remember that we are visitors in this delicate and interconnected ecosystem. Our exploration should be guided by a deep respect for marine life and a commitment to preserving the health of our oceans for generations to come. The future of our relationship with the ocean depends on our ability to balance our thirst for discovery with a profound responsibility for its protection.